Layouts and states are two of the most complex concepts to master before you can start building truly usable applications. This tutorial is going to focus on the second concept, the application states. Let's first talk about what exactly are states and why do we need them. In general, you can think of your application as being composed of two kinds of states, static states and mutable states. Static states is the information that remains constant throughout the life cycle of an app. Going back to our calculator example, the labels on the buttons is an example of static states. Mutable state is the information that changes over time, either as a response to some user action or the information that the app secures from external sources such as cloud or local storage. How one manages the mutable state is the crux of how useful the application ends up being. Of course, you will define your mutable states to be application specific. In Aptivate, the mutable states are therefore called custom states. Let's look at how to create and update custom states and how those state changes affect the display. For any app, state management is the result of careful design that can be broken down into 3 steps. The first step is to determine what is the minimal but complete set of states we require. Step 2 is to identify where should these states be defined. And finally, step 3 is to figure out how to update the states and what to update with them. Let's start with the first step. What states do we need for the calculator app? We know that a basic calculation can be seen as left-hand side operand or LHS, the operator, and the right-hand side operand or RHS equal to result. We also know we want a state that represents the current display state. So it looks like we may need 5 states altogether. Let's think about what we would like to achieve when each button is clicked. There are essentially 3 kinds of button behaviors we should define. Whenever any number button is clicked, we want to add the number at the end of our current display state. When an operator button is clicked, we want to update 2 states. The number 1 will be to take the current display state and move it into LHS. And number 2 will be to zero out the current display state so it is ready to take RHS. When the equal to button is clicked, we want to do the following. We want to take the current LHS, the operator, and the current display and update the current display with the result of the calculation. As we look at this once again, we can now safely say that we may be able to get away with just 3 states instead of 5. Those 3 states could be the LHS, the operator, and the current display. The minimization of states takes a little planning and effort, but trust me, it always leads to a better design. Step 2 is to figure out where these states will live. React-based applications manage state in a very hierarchical fashion, following closely the UI component hierarchy. In general, we want the mutable states to be defined as close as possible to the UI they control. To keep things simple for now, we will define all states at the root container. The last step is to understand how to change states. In Aptivate, you can design a series of data transformations that take a set of input states and produce an output. The series of transforms is called dependency transforms. If you're familiar with React programming, dependency transforms are equivalent to a set of pure functions. In the illustration, the first transform is a reference transform where we are referencing an existing state. The second is a literal transform where the literal is a constant value. The third one is a string format transform that can be used to concatenate a string. We can use these three transforms to combine the existing display with the string representation of the button value to produce a brand new string. The output can then be used to update the existing current display. Let's start with the number buttons. When a number button is clicked, we want to append the value of that button at the end of the current display. So we will define a click handler on a number button. On click, we want to run an update state action. Let's go ahead and choose that. The state we want to update is the current display state. After that is selected, let's define our dependency transforms as discussed. First, add the reference transform and reference the current display state. Next, let's define a literal transform where we define the constant for this button. And finally, the string format transform will let us define a template with curly braces. In this particular case, the curly braces 0 followed by curly braces 1. The input to the first curly brace is the output of the reference transform, and the input to the second curly brace is the output of the literal transform. Since we have defined the buttons individually, we have to do this for each button. There is a better way to do this using lists, but for now, we will not discuss that particular method. For more information on the lists method, please look at the list tutorial. Let's use the current display state to manage the display text box. This can be done through a process called one-way binds. Now it sounds complicated, but in reality, it is the exact same thing that we've done so far. Using a set of dependency transforms and associating the final output to the text property of the text box. Let's go to the current display text box, choose runtime state, set localize to false, and bind the state to the text box by choosing the ancestor state transform as the only dependency transform. To learn more about localization, feel free to skip to the localization tutorial video. If you are able to use dependency transforms to add commas after every 3 digits using a custom transform, you deserve an epic treat. For now, you have mastered everything you need to build large, complex apps with Aptivate. Let's look at and make sure if the buttons work as expected. Voila, they do, indeed. Let us now hook up the operator buttons. Here, we need to do two updates. The first update is to move the current display to LHS. The second update is to remember the currently selected operator in the operator state. Both of them are straightforward mappings. In case of LHS, the input is the current display, and in the case of operator, the input is a literal. Finally, let's hook up the equal to button. This is the only button for which we will need to write custom logic. We need to hook up the click action with an update state action. The state we want to update is current display. Now for dependency transformations, we will need 3 separate inputs. If you said that those 3 were the LHS state, the operator state, and the current display state, you would be 100% correct. We will need a define JavaScript function to take these 3 inputs and transform them into the output. To define a JavaScript function, we have a special transform called the custom transform. Let's add it to our dependency transform. The first screen of the custom transform requires us to define the 3 inputs. Let's go ahead and do just that. The second step is to actually create a function that will take these 3 inputs and will perform the actual calculations. We will design this by defining a switch statement for each of the operators. Finally, let's return the result. That's it. Your basic calculator is now ready to crunch some numbers. There are a variety of enhancements we can make, but that's for another day and a different tutorial.